Hello students, welcome back to MRS math class. In this lecture I am going to discuss about viscosity, okay, which is one of the most important property of the fluid, okay. Also we will discuss about what is viscous force and the related terms, okay. So viscosity means, in general we understand that thickness, okay, thickness of the fluid. If we will compare the thickness of water with thickness of honey, then thickness of honey will be more than the thickness of the water, right? So we will discuss about these things, okay. So we will consider, if you will consider a fluid flow with several layers, then in between two layers there will be relative motion and a tangential force will develop, right, to oppose the fluid flow. That is nothing but viscous force, okay, and the property is known as viscosity, okay. So if you write down the definition, then viscosity okay, so the property of fluid by virtue of which it opposes the relative motion between its adjacent layers, okay. So let us try to understand this definition by a diagram, okay. So consider this one as the horizontal fixed surface, and in this case our velocity will be minimum, that is 0, okay. And if we'll go up and up, the velocity will be more, will be increased, right? So if this one will be the highest layer, then V will be maximum in this case, okay. And the flow of the fluid is in this direction, okay. So consider any layers. So let us say this is as layer A and this is as layer B, okay. And the fluid flow is steady flow, okay, steady flow and streamline flows, okay. So if we will see the flow B, then it will accelerate the layer A. That means it will try to move fast A, and this layer A will try to retrieve this layer B, okay. So layer B will try to accelerate layer A, and layer A will try to retrieve layer B. So in between these two layers there will be some relative motion, right? So to oppose this relative motion, one force will develop, that is tangential force, which is opposite to the direction of the fluid flow, okay. So how we can calculate this fluid force, okay, by applying the Newton's law of viscosity, okay. Newton's law of viscosity. What is this? So Newton has calculated this force. How he has calculated? So let us say this force as F, which is directly proportional to the area, okay. So if we will consider these two layers, that means this area of contact is A, okay, and velocity gradient, that is dV by dx, okay. So this is area of contact and this dV by dx is our velocity gradient, okay. So what is this velocity gradient? If we will see this A, which is in the length x from the horizontal axis, from here, let this distance is x and the velocity is v, okay. And if we will go off with small distance, that is dx, then velocity change will be here v plus dv, right? So by changing small distance dx, we have small change in velocity, that is v plus dv, okay. So what is this dv by dx? Dv by dx is the rate of change of speed with respect to distance in the direction perpendicular to the flow, okay. So that is our dv by dx. So if you remove this proportional sign, we can write f equal to some constant. You can write that is eta, okay, a dv by dx. Okay, so here also we can put a negative sign, right? Why this negative sign I am writing? Because this force is opposing force, okay, so dragging force, okay, that means it is opposite to the direction of the fluid flow. So we can we can put a negative sign here. Okay, so this is our Newton's law of viscosity. Okay, and what is this constant? This eta is coefficient of viscosity. Okay, so how we can calculate this eta? Okay, what is the definition? So if you consider A as 1 unit, okay, A as 1 unit, and dv by dx, that is velocity gradient, dv by dx as 1, then we can get eta as f. Okay, that means this coefficient of viscosity will be equal to the viscous force. From here we can conclude that the more will be the value of coefficient of viscosity, more will be the thickness or viscosity of the fluid. Okay, so if we compare the water with honey, then coefficient of viscosity will be more in case of honey as compared to the water. Okay, now we will discuss about the unit and the dimension of this coefficient of viscosity. So our eta will be f dx by a dv, right? F dx by a dv. Okay, so first of all, if we will consider the CGS unit, okay, CGS unit, then this will be, f will be our dyne, right? Dx will be centimeter, and a unit is centimeter square, then dv is centimeter per second, right? So this centimeter it will cancel, so whatever the remaining terms, that is called poise. Okay, it is called poise. Okay, so if we will consider the SI unit, then it will be Newton, right? And this will be meter, and again meter it will cancel, so we can write Newton second per meter square. So this is called decapoise. Okay, or sometimes it is called poijoule, P-O-I-S-E-I-U-L-L-I. Okay, it's called PI sometimes, poijoule. Okay, so this is SI unit. Now if we will consider the dimension of eta, then so Newton, that is our ml t minus 2, right? That is t by meter square is length L square, right? So we can write dimension as m L minus 1 t minus 1. Okay, so this is the dimension of coefficient of viscosity. Okay, so this is all about the viscosity and viscous force, and what is coefficient of viscosity, unit and dimensions. Hope you understood up to this. Okay, still if you have any doubt or queries, you can ask. Okay, so this is the very basic concept of fluid dynamics, that is viscosity. Okay, so students, another important thing I want to say you, that is if you want to read the basic concepts of chemistry, one of my colleague is giving lecture on YouTube, and the channel name is BCC, that is Basic Concepts of Chemistry. Okay, Also I'll give you the link in the description box. You can follow that one. Okay students, thank you.